Yeah, so question 12 from the practice exam, we've got silver chromate. And we're told that the KSP for that equals 9 times 10 to the minus 12. So silver chromate, weak electrolyte, ionizes to give me 2 silver and 1 chromate, CO4 2 minus. To that solution, I'm going to add potassium chromate. I add 0.5 molar potassium chromate. All right, so I add 0.5 molar of that. That is a strong electrolyte that ionizes completely. That gives me 2 potassium that I don't really care about because they don't participate. But it also gives me a chromate. And so I have the common ion now in solution from potassium chromate. So we go and set up our ice table, right? Initial, change, and equilibrium. Initially, I'm going to have 0 silver, but initially I have 0.5 chromate from the potassium chromate because it's a strong electrolyte. And then when when the silver chromate goes into solution, I'm going to get, X more silver. And I can ignore that change for the chromate, basically say it's not going to matter. So at equilibrium, I'm going to have X amount of silver, 0.5, right, can be ignored. And then 0.5 molar of that chromate in the solution. So now we can plug that into our KSP. KSP equals the concentration of silver squared times the concentration of chromate. So at this point, you might be wondering why I didn't call this 2X, even though it is 2 silver, right? Because this is my only unknown, I don't have to call silver 2X because it's the only thing I'm solving for. If I didn't have either concentration and I had to solve for both, then yes, I would have 2X and X because that's the ratio between these two. But in this case, I know chromate, I don't know silver, so I can just call that X. I do not have to call it 2X in this case. So my KSP, 9 times 10 to the minus 12 equals X squared. I still have to square it because that's my KSP expression. Times 0.5. So I'm going to divide both sides by 0.5. And I get X squared equals 1.8 times 10 to the minus 11. I take the square root of both sides. And I get X equals 4.24 times 10 to the minus 6 molar silver. That is also the molar solubility of silver chromate. Yeah, but they're only asking for what's the concentration of silver. So there's the concentration of silver I would need in solution to precipitate silver chromate, given the concentration of chromate I have from potassium chromate. If you did this as 2X, you would still get the same answer because you'd put in 2X squared, you're going to square it. You would divide by 4, take the square root, and then you're going to get X, and then you'd have to plug in X up here to multiply it by 2 again. You would end up with the same answer, even if you did 2X there. But we don't need to set it as 2X because it's our only unknown in this case. So 4.2, 10 to the minus 6 molar silver. Two significant figures, our concentration 0.50 is 2 significant figures. KSP is 2. My apologies.